So here is one question. Someone has sent it as a doubt, and it's in fact a good question. I'm explaining this. It is written on the board. The question says, if px and gx are two polynomials such that degree of px greater than equals to degree of gx and gx not equal to 0, then we find polynomial qx and rx such that we can write px in terms of gx, qx and rx. Means px is equal to gx into qx plus rx, where either Rx would be 0 or degree of Rx would be less than degree of Gx. This is the statement given. We have to find out whether this is a true statement or false statement. Fine. Since in the question it is given degree of Px greater than equals to degree of Gx. So from here two possibilities are there. Either degree of Px would be more than degree of Gx or equal to degree of Gx, right? So taking both the cases one by one, suppose case 1, when degree Px greater than degree Gx. Okay. Now one example I am taking, suppose I am assuming that Px is a quadratic polynomial. Let's suppose x square plus 5x plus 6. Now degree of gx should be less than degree of px, so I am assuming gx as a linear one. Suppose x plus 2. Fine. Here degree of px is quadratic and degree of gx is x plus 2, which is linear degree 1. Now what will be the rx? I have assumed x plus 2. I know that this is the factor of this polynomial. So let's check. And by factor theorem we know, right? If we divide we will get 0. Let's check it by the long division method. So if we divide px by gx, fine. So here x square plus 2x minus minus, it is 3x plus 6 and then plus 3. So 3x plus 6 minus minus cancelled. See, we are getting rx as 0. We know this is the factor theorem, right? If a polynomial is divided by its factor, then definitely remainder will be 0. So here we are getting 0. It was given in the question, right? So if the gx is a factor, rx remainder will always be 0. Fine. Here I had assumed that gx is factor. Let's assume that it is not a factor. Suppose I am taking x plus 5 as gx. Now what will be the rx? Let's see by the long division method. X square plus 5x plus 6. So x square plus 5x minus minus cancel 6. This will be the remainder, right? Rx. Here the degree of gx is 1 and degree of rx is 0. Now we are finding that degree of rx is less than degree of gx. It is 1 here, it is 0 here. So it is again verifying this one when I have not taken a factor of px. Fine. Okay. Now we can take another example. Here I had taken a quadratic one, right? So what will happen if I take a cubic one? Suppose x cube plus 1 and I am taking gx as x square minus x plus 1. I know that this is the factor by the identity, right? It is a factor of this one. So by the factor theorem, if it is a factor, then definitely remainder will be 0. We should get this one. So check it by the long division method. It is x cube plus 1, x here. So x cube minus x square plus x minus plus minus x square minus x plus 1 plus 1 x square minus x plus 1 minus plus minus cancel. See, again we are getting rx as 0 since it was a factor. Now what will happen if gx is not a factor? Suppose I am taking x square plus 1 as gx and its degree is 2. So find out what is the rx or its degree by long division method. X square plus 1 x cube plus 1. So x cube plus x minus 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 x plus 1, right? Now it is not divisible, so this is the rx. Fine. This is qx. Fine. Okay. Now see, here the degree of gx is 2 and here the degree of Rx is 1. So again satisfying that degree of Rx 1 less than degree of Gx, which was 2 here. So it is satisfying this one. So when we take the factor, we will get this one, and if we are not taking the factor, then we will get this result. Okay, this is the example when degree of Px greater than degree of Gx. Another case, case 2, when degree Px equal to degree Gx, right? What will happen? Okay, so just assume Px as x square, I am taking the same one, x square plus 5x plus 1, and Gx I am taking again same, x square plus 5x plus 1, because we have to take same degree, and here it is a factor, obviously remainder will be 0. We will divide, we will get qx as 1 and remainder 0. So we are getting again remainder as 0, Rx will be 0. Fine. Now what will happen when it is not a factor? I am supposing that this is x square plus x, then what will be the Rx? Fine. Here the degree I have assumed both have same degree, and degree of Gx is 2. So x square plus x, when we divide x square plus 5x plus 1, it will be 1. So x square plus x minus minus, we will again get 4x plus 1. Now it is not divisible, so this is the Rx. Here the degree of Gx was 2 and degree of Rx is 1. So again we are able to see that degree of Rx, which is 1 here, less than degree of Gx, which is